Again to the another tutorial, and in this tutorial we're going to talk about one another Android architecture component that is called Room. And Room is a persistence library which act as a wrapper between your application code and the SQLite storage. So you can think of SQLite as a database that runs without its own server and saves all the application data in an internal file that's only accessible to your application, right? So if the device is not rooted, so rooms room sits between the application code and the SQLite Android framework and handles the necessary CRUD operations like create, read, update, and delete, while exposing an abstraction that your application can use to define the data and how you want the data to be handled. Okay, so this abstraction comes from in the form of the following object, that is this one, abstraction with comes in the following objects like entities. So you can with entities you can specify how you want your data to be stored and the relationship between your data. DAO is the operations that can be done on your data. Okay, a data access object. Okay, and database is where you can specify the configuration that your database should have, the name of the database and the migration scenarios. Okay, so to make it more clear, you can see this simple diagram where like this diagram shows the relationship between your application and the Room components. So you can see how the Room components interact with each other, like how the Room components interact with your entity, right, DAO and database, right? Let's assume that you want to make a messaging app and store each message in your local storage, right? In this case, entity would be your message object. This will be your message object, which will have an ID and will contain the contents of the message, the sender and the time, status, and so on. So in order to access message from your local storage, you will need a message DAO, okay, which will contain methods such as insert message, get message from user, delete message, and update message. So in addition, since it's a messaging application, you will need a contact entity to hold information about the sender and receiver messages. The contact entity will contain information such as name, the last name, phone number, email, and so on and so on. So in order to in order to access the contact information, you also need a contact DAO interface, such like a message DAO. You have create DAO methods like create user, update user, delete user, get all user. Both entities will contain a matching table in SQLite which contains the field we defined inside the entity class as column. In order to achieve this, we will have to create a messaging database in which we will reference both entities. So right, so this was a kind of a example. So if there is no like Jetpack library like Room, we have or similar DAO libraries, we will need to use the standard Android framework like SQLite components, okay, which is pretty much tiresome and lengthy process. And like using Room, we will try to reduce a lot of boilerplate codes, right? And we will also reduce the query and all those codes, right? So by default, Room does not allow any operations on the UI thread to enforce the Android standards related to input-output operation. To make asynchronous call to access data, Room is compatible with a number of libraries and frameworks such as Kotlin coroutines or RX Java like data and so on. So we should now have some idea of how Room works and its main components. So we will now look over each of these components like entity. We'll be looking each of these components like of the Room. That will be like entity. Step by step we will create a simple example entity, DAO, and database. So let's create the entity as I have described in the example. So let me shift it here. So entities serve two purposes. Okay, actually to define the structure of the table and to hold the data from the table row. So let's use the same scenario that I explained you before about a messaging app, and define two entities, one for the user and one for the message. The user entity will contain information about who sends the message, while the message entity will contains the information about the content of the message, the time it was sent, and the reference to the sender of the message. So let's create the simple entity called message. Okay, let me just shift it for the moment, and let me create a new package called entity. Okay, so in this new package called entity, we will try to create a new entity class, which is obviously a data class called message. Okay, so here in this entity we have a but okay, so guys, there is another interesting thing is we are missing is obviously we have to add our libraries, right? So we have to just implement our libraries for our room to implement a room. So uh, let me go to my build.gradle file and just add the necessary room library. So we have a room runtime, and we are using this version persistence. No, not this one, guys. Room runtime. Okay, so this is the library that we have to implement, and we need to sync it first, then start creating our entity. Okay, let's wait for the necessary libraries to be updated, right? And then now we will just try to create the necessary primary key to generate to true, and column info name message id full id of long. So now we have another info is called text. We have also a time, it's a long, and finally the user id, which is also long, and also we have a location. Okay, so yeah, it can be nullable. So we have to pass the necessary annotation of column info name is text, default value is empty string. We also have a column info of name, time, and column info name user, and finally this location is embedded. And let's also assign the entity name, entity, table name, messages. Okay, so this is the we create the entity for message. Now we also need to create okay, sorry guys, let me also create the location. data class with so this is not the location but column info. We have let double, we have long double, name is a string, column info name let. So we also need the similar, this is long and this is a location name. Okay, so this is the location here. Okay, so here we have created the entity for our message object. Okay, and let's also create the entity for our location, no sorry, user, data class user, and we have a user has ID, user has the first name, user has the last name, user has the last online long. So we have an entity with table name equals to users, and now we have the necessary, this is the primary key with column info, the name will be user ID, and similarly we also need to define the column info for each and every attributes here. Obviously it's a first name, last name, and last online. Okay, so we have all these necessary attributes, and we have declared two entity, right? One is a messages and the another is a users, right? User entity. Okay, so as you can see, the entity are just data class with annotations which will tell room how the table should be built in SQLite. The annotation we used are as follows. Okay, the entity, this is the annotation that we are using as an entity annotation, defines the table. By default, the table name will be the name of the class, but you can also change your name, right? Method, okay, you can also change your name with this table name method, but by default is the name of this class. Okay, this is useful in situations where we want our code of obfuscated but wish to keep the consistency of the SQLite structure. The column info defines the configuration for a certain column. The most common one is the name of the column. We can also specify a default value, the SQLite type of the field, and whether the field should be indexed. Okay, so the primary key, as you can see here, indicates what is our entity that will make it unique. Okay, every entity should have a primary key, so to make it a unique, right? So they should have at least one primary key. Okay, it's very compulsory. So if your primary key is an integer or a long, then we can add the auto generate field to true. Okay, and this means that every entity that gets inserted into the primary key field is automatically generated by SQLite. Okay, so usually This is done by incrementing the previous ID. So if we wish to define multiple fields such as primary key, then we can adjust the entity annotation to accommodate this, such as you can also accommodate in this way, like primary keys. So you can have multiple primary keys like ID, time, so you can just pretty much adjust in this way if you want to define a multiple keys, right? So let's assume that our messaging application wants to change location. So locations, obviously, as I have defined here in this data class, has a latitude, longitude, and the name of the location, right? So we can so we added them in our message class, but that this will increase the complexity of the class. So how it increase the complexity, because we have added the another data class, right? So uh, so we created, and we have to create another and reference the ID actually. So the problem with refreshing the ID is that we would then query the location entity every time, and we want to we query the message whenever we have to query the message object, right? Having this as an extra entity, this will create complexity, like we have to also query each time we query the message, we also have to query the location entity, right? So Room has a third approach through the embedded annotation, as you can see here. So this embedded annotation will make it easier, like that means your location, this data is pretty much embedded with your this entity class message. So actually this code will add three classes to your three columns to your message table. This allows us to avoid the having object with a large number of fields while keeping the consistency of our table. So if we look at our entity, we'll see that they exist independently. The message entity has a user ID field, but nothing is preventing us from adding message from invalid user. This may lead to situations where we collect data without any purpose. If you want to delete a particular user along with their messages, we must do so manually. So Room provides us the way to define the relationship using the foreign key, right? So how can we define the foreign key? Is these are primary keys. Also we have foreign keys, foreign key, and we have an entity user class, parent columns, we have a user ID, child columns, we have a user. On delete we have a foreign key cascade. Okay, so so Room provide us the way to define the relationship to delete the particular user along with their messages. So we can do this manually by adding this foreign key, right? So for example, if you want to delete your messages if you want to delete a particular user along with their messages, we can also do this manually. Okay, let's say like this is the foreign key, using this foreign key, guys. And okay, so every time we add a message to the table, there needs to be a user entry in the user table. You see, so if you try to delete a user and any message from the user, any message from the that user still exists, then by default this will not work because of the dependencies. However, we can tell a room to do a cascade delete, which will erase the user and the associated messages, right? So this is the situation. And so now let's go and understand about the DAO, the data access object. We can also now create a DAO. So DAO is pretty much like an interface, okay, consisting of all the methods for doing our CRUD operations, right? Create, read, update, and delete. So okay, let's go and create our DAO with our package DAO. Okay, so DAO pretty much specify what we are gonna do with our data, right? So let me create a message DAO. And it will be pretty much like an interface, as I told you. And it is just helping us to do some CRUD operations, right? So ideally each entity should have a corresponding DAO, but there are situations where crossover occurs. So crossover means usually this happens when we have to deal with a join between two tables, right? So let's create our DAO for our messaging entity. So we have function insert messages, variable argument messages, messages actually. Okay, we insert message, so insert with the annotation of insert on conflict strategy on sorry conflict strategy is your replace. If there is any conflict, just replace it, right? So then you also have a function update messages. So our arg messages okay, so here also we have update annotation, then we have delete messages, var arg messages message of type message, right? And here we have delete annotation. Then also we have like we have a function to load all messages. So here loading all messages, we have a list of messages, and then here we have a query to load all the messages. That we will do is select from messages, right? So this is the situation. And we have finally function load messages from user after time. So you have a user ID, that's a string, and then you have a time, obviously it's a long, and finally it's return the message, right? So return the list of messages. Okay, so here we have to also pass the query of select from messages where user ID and time equals to time. Okay, so yeah, this is the scenario, guys, for our message DAO. We also have our another DAO is for you can create another DAO for user it's an interface, and we have our user DAO to insert user, pass the user. Obviously we have to annotate with the DAO. Let me see. Yeah, we have to annotate with the DAO. Okay, I was missing in the message part. Okay, here we have to insert, so obviously the insert annotation with the on conflict strategy is obviously to replace it, and then we have to update user, passing always the user. We have function delete user, obviously we pass the user, and here we have the update, and here we have annotation of delete. Okay, so finally we also need to load all the user, right? So function load all users, and we have a list of user, right? Here we are gonna select star from users, right? So this is the situation, right? So we have defined these two DAO, right? So to perform multiple CRUD operations. Actually, the query annotation stands out from all the like other annotation is because we are passing the query, right? This is where we use SQLite code to define how we read operations. Okay, how our operations work, right? Read operation works like select star means we want to read all the data from every row in the table, table where we populate all which will populate all our entities fields. So the where star from, and like, okay, let me see. Yeah, if you see here, select from and messages is the table, and where clause indicates a restriction that we want to apply in our query. So this is the restrictions. So these are the restrictions, like user should be have the same user ID and time should be this time, right? This is our situations. This is how we create our DAO to perform the CRUD operations. Using this query we can just filter messages from multiple users, right? Okay. We can also have actually create another data class always inside this, which will be called data class of text with time, right? You can define the necessary columns info. The name is the text equals to string, not the string, it's of type string, sorry guys. And we have also a time, this is of time, this is of type long. So we have a text with time to filter our, and yeah, similarly we can also actually in our message DAO load text with time function, load text and time, so which will give you the list of text with the time with the query. that we're gonna do is select text and time from messages. Okay, you can also, you don't need to always specify from the entire table, but also from the text and time, you know, from the messages table, right? So messages table is yeah, messages table has text and time, right? So this will actually what we did this here pretty much helped us to extract the information from certain columns at a time, not the entire row, right? So mm, so also we can use message with the user. Yeah, so if you want to add the user information of the sender to every message, here we will need to use the similar approach that we used previously, like message with user. Let me also create another data class, message with the user, and it's pretty much embedded with the message, and obviously embedded with the user. So by using this new data class, we define the query, load messages and also user, like load messages and users, which provides us the list of messages users with users. The query is in this format. We have a select from messages, you have a inner join the users on users dot user id equals to messages dot user. Okay, so this is also you can also have a complex join here. Yeah, so you can have multiple, you can perform multiple DAO operations like this. Okay, so now finally, how do we set up the database? So in the room we have another component which is called db. It's a database, it stands for database. So we are gonna create our database class, my chat message database, which is okay, actually which is a abstract class, and we will also implement like inherit the room database, and which will have a companion object of private latent val chat database message database function get database application context app context, pass the context with the chat message database. So if not chat message database is initialized. If not initialized, then chat message database will be initialized with the room database builder, and you create your context, you pass your context, you have a chat message database class, and the name of the database, that is chat db, and finally you build it, right? and we have to obviously return our database messaging database. So this is how we create our database, and then we also have another abstract functions like user DAO, message DAO. Okay, so we are missing something here, that is obviously our database annotation, passing the entities, that is our user class and our message class. It's pass these entities, and the version of your database, okay, starts from version 1. Okay, so this is a simple implementation of our Room database. Okay, so this database annotation, with this database annotation we specify what entities go in our database and our version. Then for every DAO we define an abstract method in Room database. So this allows the build system to build a subclass of our class, in which it provides the implementation of this method. Okay, the build system will also create the table related to our entities. Okay, so the get database method in the companion object, this actually illustrates how we can create an instance of the chat database class. Um, uh, Ideally, there should be one instance of the database of our application due to the complexity involved in building a new database object. However, this can be better achieved through the dependency injection framework. Okay, so we will be discussing this in the next tutorial, where we will be introducing dependency injection. Okay, let's assume that that you have released your chat application, so right, chat message application, and your database is currently version 1, but your users are complaining that the message status feature is missing, so you decide to add the feature in the next release. This involves changing the database structure, which can impact database that has already built their structure. So luckily, Room offers something called migration. In this migration, we defined how our database changed from version 1 to the next release. You have to update your version with version 2. Okay, after you make any changes in your database. That's it, guys, and okay, so what next? We can also actually check out how we can do the migration, the necessary migration. It's for example, if I make, okay, so this is our normal database and we make a release, right? So if I make any changes here, now I'm gonna make some changes to our the column, that I'm gonna add another interesting column here after user ID. I'm gonna add also the status here of type int. My column info is obviously the name is status. Okay, so I made some changes here, right? So here we added this status flag now. So now we have to change our obviously when we release these new changes here. Okay, let me also comment this new changes added. Okay, so if you make any changes like this, and that I'm doing here, new changes added. So how will you update your database is you have to update your version to 2 after change, after migration actually, and then you have our okay, private val creation from 1 to 2 equals to object migration, room migration 1 to 2 and okay, so this is the migration scenarios. So you have a migrate function and you implement your database that execute the SQL. So here after table messages add column status integer. Okay, so this is the scenario, and obviously we will also have to add here the before the build we have to add migration, sorry guys, add migrations and migration 1 to 2. okay, okay, so this is the way of migrating. Okay, so now let's move further. So also, like, there might be situation if we look at our message class, we have noticed that we define time as long. So in Java and Kotlin we have the date object, right? So here if you see the time is defined as long, but in Java and Kotlin we have a date object, which might be more useful than the timestamp of the message. Like luckily Room has also the solution for this, like of a form of a type converter, right? So the type converter is also like provided by our Room library. So let's modify the user like last online to date, and when we move this we have a so now we modify this, let's create our Kotlin class called date converter. okay, we have function from value long of type nullable, and it returns the date of type nullable. okay, and returns the value, check the null, and if it is not null then returns the date. Okay, we import the necessary date, and here we have to use the type converter, which is provided by our Room database, right? Type Room library function to date, right? Date which is of type nullable, and it returns the long return date time. Yeah, so this is our date converters. So now pretty much here, let me also import the library here, and it's we just have our go to our database, and after the migration version you can also have a type converters with the date converter class, right? Okay, so yeah, this is the situation, right? So Okay, this is the entire explanation about the room database. Actually, also the important concept that you have to understand is Room works well with the third-party library and frameworks like Live Data and coroutines. Okay, this is very useful because obviously we are going to use our view model and Live Data for data stream and coroutines also for our data stream, right? To pass the data from fragment to another, right? So this solves two issues, right? Multi-threading and observing data changes. So Live Data will make the query annotation method in our reactive, which means that if new data is added, Live Data will notify the observers. So right, so for example, let me go to my load all messages, or right, you can just use live data here. Pretty much, it's pretty working fine with this data stream. Like Room works well with this data stream frameworks like Live Data and also coroutines. You can also pretty much use Flow, right? Or Live Data. And yes, that's it, guys. So what more? So in this situation, yeah, we can also use our yeah we can also use for example, let's go to our user DAO. Load also use flow. We can use flows here, state flows here, yeah, for coroutines, yeah. And that's it, guys. So this is all about the simple introduction about Room, and hope it was really useful. And yeah, in the upcoming lectures we'll be just creating our simple application using this information that we have learned from this tutorial. And yeah, catch you up in the next lecture, guys. Thank you.